Hey folks, today's topic is the rational zero test. So if you remember back in 2.3, I think it was, we went through a whole list of different ways that you can find zeros. So there was like, if your thing is already factored, you would just CPP. If your expression wasn't factored and it was a degree 2, you could either factor it or do the quadratic formula. We could also do dopes, or we could just solve. And then there was the higher exponents where you would factor out or do that weird factoring. If you don't know what I'm talking about, that's a pretty big, that's one whole page of the test, is your ability to recognize those different moves. So I would definitely go back and look at 2.3 if you have no idea what I was just talking about. But today's topic is the ability to find zeros when all those other methods don't work. So this rational zero test makes it so that it narrows down from infinitely many possible numbers. It gives us a list of ones that it's a finite list. It still could be a very long list, but it's a finite list, which means we could test all those numbers to find out if any of them work. Let's just first review kind of how this, or what a factor is, and then how to determine what's left over once you divide by a factor. So let's review that. A factor is something that goes into something else. So like, for instance, the number 2 is a factor of the number 12, because 2 divides into 12 with a remainder of 0. That's what we consider a factor. So this expression, they've already told us that these two things are factors, which means if I took this expression and I divided it by this, I would get a remainder of 0. Or if I divided it by this, I would get a remainder of 0. Now, what we want to do is we want to find as many factors as we have exponents. Remember when we did zeros with multiplicities? This is the same idea. So they gave us 2 factors, and we have to find the other 2 factors. So what we're going to do is we're going to divide these out. We're going to divide each one of these factors into this, and then take what's left over and see if we can break that down by factoring. So if I want to divide by this and then divide by this expression, I can do it one of 2 ways. I can either do long division or I can do synthetic division. If I want to do synthetic division, what are the requirements? If you can remember. Hopefully you said that you have to have a coefficient of 1 and a degree of 1 in your divisor. And that's exactly what we have here. So if I'm going to do synthetic, I need to first turn this into a 0. So the 0 associated with x minus 2, if I ZPP'd that, I would get x equals 2. And then when you do synthetic division, the 2 goes in the little house. Then we list our coefficients: 2, 7, -4, -27, -18. A little error alert there. Leave yourself a little space. Error alert, make sure that you're going order of all your exponents. 4, 3, 2, 1, none. So I didn't have to add any zeros. So we've done synthetic division already. First thing drops. Then you multiply 4. Then you add 11. Then you multiply 22. Then you add 18. Then you multiply 36. Then you add 9. Then you multiply 18. Then you add 0. Which is good that we got a remainder of 0, because they told us that x minus 2 was a factor of f. So now we can rewrite this. If this was an x to the 4 and we broke it down by an x to the first, that's going to make this a 2x to the third plus 11x squared plus 18x plus 9. Okay, can we factor this? No, we don't have a method when factoring with cubes when there's 4 terms. You could try to do factor by parts, but you'll see quickly nothing goes into 2 and 11 besides 1, and 18 and 9 are both divisible by 9, so you're not going to be able to do factor by parts. So we have to break this down again. So this is our hint. I'm going to circle this. So I want to say note, not degree 2. So break down again. So my goal is to break this thing down, factor it into as many small pieces as I can. And since I can't factor this, then I can't factor a cubed in this scenario, then I need to try to divide it again. So We're going to now find the 0 of this factor. ZPP it, we get x equals -3. So I can divide synthetically. If I can't, then I've got to do it by long division. So now I'm going to take this, and I'm going to divide that by -3. So my coefficients are 2, 11, 18, and 9. The 2 drops. Multiply, that's -6. Add, that's 5. Multiply, that's -15. Add, that's 3. Multiply, that's -9. Add, that's 0. That's good that we've got a remainder of 0 again. I mean, think about what we did here. Let's say we took the number 12 and divided it by 2. Could we get then an answer? Our result would be 6, which is still divisible by 3. We just keep breaking this thing down until we get something that's nicely factorable. So this was an x cubed. We broke it down by an x, so we now get 2x squared plus 5x plus 3. Now my math voice is happy because this is something that's factorable. So I'm going to go back to blue. Overall, this would be what? This is just regular factoring. How do I want to write this? I guess I'll go like this. 2 times 3 is 6. To make a 5, they've got to add. They got to be positive, I should say, so it's got to be 2 and 3. It can't be 6 and 1. That one is a sneaky one because there's 2 options. I mean, only one is right, but it makes you think of 2 options. So 2 and x, that makes the 2. I need to make a 3, so that has to be a 1. That has to be a 3. They got to add up. And then remember, every time you factor, quickly distribute and see if you factored it correctly. You should get the expression that you had before. So I would get 2x squared. 2 plus 3 is 5. 3 times 1 is 3. Good, we did it. Now, don't forget, you need to make an actual list of all your answers. This wants all the factors. So they gave us we found 2 factors, 2x plus 3 and x plus 1. But remember, we're supposed to have 4 factors because this is an x to the 4th. Well, they gave us 2 of them. X subtract 2 and x plus 3. What do you think? Okay, so let's try this again. In this case, they're asking us to find zeros. No big deal. That just means we find the factors and then ZPP them. Now, why did they only give us 1 factor this time? Up here, they had to give us 2 factors. Why did they only give us 1? Well, hopefully you notice that this was an x cubed. So once I divide this factor into it, I'm going to break it down and make it into an x squared, which once you get x squared, you can either quadratic or you can do the regular factoring. Can I do synthetic? Yes. Coefficient 1, exponent 1. So I'm going to turn this into a 0. X equals 4. So 4 goes in the little house. My coefficients are 6, -23, -6, and 8. 3, 2, 1, none. No problem there. The 6 drops. That's 24. Add it up. That's 1. That's 4. That's -2. That's -8. That's 0. So then this becomes 6x squared plus x subtract 2. So now, because we got a degree 2, so either factor or quadratic formula. So here's hoping we don't have to do the quadratic. Let's see, 6 times -2. Actually, I'm going to draw this up here. So 6x squared plus x subtract 2. My factor, x factoring, 6 times 2 is -12. That makes 1. Yep, that works. 4 and -3. Okay, so 6 and 1 won't work because it won't build either of those, so I got to go with the old 2 and 3. If you don't remember how to factor, go back and look at 0.2 or 0.3 notes. This is being able to factor is a big deal in this class. That's going to make the 4. That's going to make the -1. All right, now, as I write my answer, I've got to pay attention to what they asked for. They asked for factors. They didn't ask for they asked for zeros. They didn't ask for factors. So now I have to ZPP all of these to get my answer. So my zeros are, if I ZPP this, I'm going to do it in my head, set it equal to 0, bump over the 1, divide by 2, so that's 1/2. ZPP this, bump over the -2, divide by 3, that's -2/3. And then where's the third 0? Remember this was an x cubed. Well, the third 0 is the one that we found, or sorry, the one that they gave us. So the next logical question is, what happens when, looks like in my old notes I wrote these with x equals. You could write x equals in front or just list them. So we should get in the habit of writing x equals. X equals, x equals, x equals. I think I like that better. Anyway, so the next logical question is, well, what do we do when they don't give us a factor? How do we find what to divide by if they don't tell us one of the hints? Well, that's this thing called the rational zero test, the RZT. Rational zero test. And the rational zero test narrows down from having to check infinitely many possibilities down to a finite list. Now, it's not necessarily a very short list. Sometimes it's a really long list, but at least it's a finite list. So you will want to find your list, to find the possible rational zeros, you would take the factors of the constant and divide by the factors of the leading coefficient. So let's just quickly review which is which here. The constant, the number without an x. The leading coefficient is the coefficient in front of the highest degree term. So usually we put it in standard form, so it's the first thing and the last thing, but sometimes it's not. So you have to grab the highest term divided by the lowest term. So what does that mean? Well, in this case, let's make a list then of all the factors that are of the constant divided by of the coefficient. So I'll start off. So what numbers go into -10? Well, 1 or -1 works. So plus or minus 1. Because it's negative, you could divide that by a positive or a negative and still get a remainder of 0. Remember, the definition of a factor is something that divides in with the remainder of 0. So what else works? I like to go in order. 1, and then 2, and then 5, and then 10. Now, if you wanted to list 1 and 10, and then 2 and 5, it's fine. Okay, let's see. What are the factors of 9? Well, 1 goes into everything. 2 doesn't work. 3 works. 3 and 3, but you don't have to write it twice. 4, no. 5, no. 6, no. 7, no. 8, no. 9. All right, so those are all the factors. So to make my list of possible rational zeros, in other words, to find the numbers that we should check in the little synthetic division box, we would take everything on the front and everything on the top and divide it by everything on the bottom. So that means I'm going to take the 1 and I'm going to put it over the 1, then the 1 over the 3, then the 1 over the 9. Actually, let's do it this way. Everything on the top over the 1. So what's 1 divided by 1? 1. Now, because these are positive or negative, I'm going to keep the plus or minus. Then I'm going to take the 2 and I'm going to put it over the 1. What's 2 divided by 1? 2. What's 5 divided by 1? 5. What's 10 divided by 1? 10. Then I'm going to take everything in the numerator again, but I'm going to divide it by the 3. So 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 5 divided by 3 is 5/3. 10 divided by 3 is 10/3. Now, sometimes these will reduce and make another number that you already had in the list. You don't have to list it twice. You can if you want to. You don't have to. Then I'm going to take all these numerators and put them over everything in the numerator and put it over the 9. So 1 over 9 is 1/9. 2 over 9 is 2/9. 5 over 9 is 5/9. And then finally, 10 over 9 is 10/9. Now, like I said, this list is not necessarily short. This is a long list sometimes. And in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2 because there's plus or minus. So there are 24 possible numbers that you could check for this in the case of this function. Now, let me give you a hint. full disclosure here, I'm not going to give you one that you'd have to test like all the way down to the 2/9, -2/9. So my hint to you is start with the lowest, nicest numbers first. I'm going to try to set most of them up so that one of the whole numbers work. Now, maybe it's going to be -5. That takes a little bit longer to get there, but don't start with the fractions. Start with the nice numbers. So let's try to do this now. So right away, they're asking us to find zeros. So let me underline that. They want us to find zeros. Darn it, why did I circle that one and underline that one? Oh, man. No circle. This is a note for me for next year, sorry. We want to underline, not circle. All right, so we found all zeros of our function. So that means we want to make a list of all the numbers that might work. That's what we call the rational zero test. So the RZT would be all the factors of the constant divided by the factors of the coefficient. So the factors of the constant are 3 and 1. So that's plus or minus 1, plus or minus 3. Over the factors of 2 are plus or minus 1, plus or minus 2. Now that's not the list. That's what we use to generate the list. Then to generate the actual list, we take the numerator divided by everything on the denominator. So 1 over 1 is 1. 3 over 1 is 3. 1 over 2 is 1/2. 3 over 2 is 3/2. So like I said, this is the kind of list that I'm going to expect you to be able to do. Then from here, this is kind of a pain. You just have to guess and check. You have to try something and see if it works. I'm going to guess -1 first. Why? Just because. Actually, because I know it won't work. So -1 into. Now I can do this synthetically. So 2, 3, -8, 3. I go 3, 2, 1, none, so I don't have to add any zeros. The 2 drops. That's -2. Add it up. That's 1. That's -1. That's -9. That's 9. That's 12. Because this, our remainder, is not 0, -1 is eliminated as something that does not divide into f of x. So we should try something else. My advice is to start small. So we tried -1. Let's try +1. 1, 2, 3, -8, 3. 2 drops. That's 2, that's 5, that's 5, that's -3, that's -3, that's 0. Yay. Because we got a remainder of 0, that means that 1 is a 0 of my function. So I'm going to go back and circle that. Now, from here, you can keep guessing if you want to. You can go back and try to guess again, because how many of these zeros do we have to find? There should be 3 total zeros. We found 1. There are 2 more out there. So you can keep guessing if you want to, or you can realize that this was an x cubed that you broke down once. So that means that this is an x squared. And when I've got an x squared, that means that's something I can factor. All right, so I need to build a +5 with a -3. So that's going to be a +6 and a -1. Okay, so I found one of my zeros. This is a 0, so be careful. Let me get a different color here. I think I want to highlight that in a different color. This is a 0. These are factors. So make sure that you have everything organized in the order that they want. They want zeros here, so I'm now going to make a list of all my zeros. My zeros are 1. Darn it, I wanted to do x equals. X equals 1. X equals, now I got to, if this is a factor, I got to ZPP this. So that's 1/2. I got to ZPP this, that's -3. I don't know why I keep writing so many x's. I'm going to rewrite this for next year too, sorry. You don't have to write out the x's every time. This is better. No, I really don't like it. What a mess. Next year's notes have to get cleaned up a little bit. Okay, let's see if you can do it now. So I'm going to encourage you to pause here, try to find all the factors this time. So this time we're looking for factors of f of x. All right, let's see how you did. The first thing we have to do is find the possible rational zeros. So factors of the constant, 1 and 7, divided by factors of the coefficient, 1 and 5. 1 over 1 is 1. 7 over 1 is 7. 1 over 5 is 1/5. 7 over 5 is 7/5. All right, start guessing and checking. Let's see, I'm going to guess 1 first. So that's 5, negative 46, 84, negative 50, and 7. 5 and 5, negative 41, negative 41, 43. 43, yay, negative 7, 0. Yay, smiley face. If I get a remainder of 0, that means that this is a 0. Now, a little note here, you could note x equals 1 could work again. So sometimes that's kind of annoying. I mean, you don't have to guess 1 again because we've got to still break this thing down, right? This is a 5x to the third because it was to the fourth. We broke it down once, so that's an x to the third. X squared, 43x minus 7. So we're going to have to break this thing down again. Just like the number 12 is divisible by 2 and gives you 6, but then that 6 could be divisible by 2 again. So you could use 1 again if you wanted to. Now, if you want to, go for it. If you don't want to, don't go for it. I don't care. I'm going to choose to go with, I got to take this. I got to break it down. I'm going to try negative 1 next. So negative 1. Now, I don't want to go back to this. I could, but then I've got to just keep guessing and checking all of these until it works. My goal is to take this thing and break it down until I get to an x to the second. As soon as I get to an x to the second, once I get a degree 2, I can either factor or do the quadratic formula. So I'm going to take this and break it down again. So I want to break down 5, negative 41, 43, and negative 7. 5 drops, that's negative 5, that's negative 46, that's 46, that's 89, that's not a good sign, minus 89, I don't know what that is, but it definitely is not going to give me a remainder of 0. I didn't get a remainder of 0, which means I can now eliminate negative 1 from the possible list. It'll never work again. So, negative 1 didn't work, so I'm going to try something else. I'm going to move on to 7 or negative 7. I'm going to try 7 first. Now, don't go back to the beginning again, because if you go back to the beginning, that's an x to the fourth, which means you need to still break it down twice. So I'm going to go back to this spot, and I'm going to do this again. Go from here, and I'm going to go again, but this time I'm going to try to use 7. 5, negative 41, 43, negative 7. Ooh, I didn't leave myself much room. 35, ooh, negative 6, negative 42, 1, 7, 0, smiley face. That means that 7 is also a 0. So how many zeros are we supposed to find? This is an x to the fourth, so we should have found 4 of them. Well, we've only found 2 so far. So you could keep guessing if you wanted to, or you could recognize that this is now 5x squared minus 6x plus 1, which means it's factorable. I need a negative 5 and I need a negative 1. So I now have 2 zeros and 2 factors. What do I want them all listed as? I want them all listed as factors. So now I'm going to grab all of these and I'm going to convert them into factors. So let's write our final answer as I want factors. So 2 of these are already factors. So 5x minus 1, x minus 1. And then these are zeros. So I have to do a reverse ZPP to turn them into factors. When I reverse ZPP this, I get x minus 1 again. Well, if x minus 1 is already listed, that's going to be a multiplicity of 2. So I'm going to just put the squared. If you want to list it again, that's fine. It just shows you really aren't catching on how factors work. But I mean, you'll still get full credit. My other 0 was x equals 7. So when I bump the 7 back over with the x, it becomes an x minus 7. And now I have a total of 4 factors, which is what we knew should have happened because this was an x to the 4th. All right, so give it a try. Take your time. Make sure that you memorize this, the possible rational zeros. I don't think I give that to you if I remember right. Ask me in class. All right, talk to you later. Good luck.